In this video, we're going to go through the exponent rules and logarithm rules that you've just learned. Those rules would be writing things in exponential notation or logarithmic rotation, as well as all of your power rules that you've learned from a number of years ago. So the first question I asked was 351, and so here you can see a number of different equations or expressions, and we have to combine those in such a way so that you would only leave positive exponents. So that means if they're negative, you may need to move them into the bottom. So any of the coefficients like 12.5 come together to make 6. You have x squared times x to the 5th. Those combine together and you add them to make 7. And the y's that you combine, 4 plus 1, would be y to the 5th power. Okay, so then looking at B, I'm not going to do all of these. We'll jump around a bit. 16.25 makes 4. 4 times 2 is 8, so you would have an 8 when you combine those. For the s's, I see 3 s's here and 6 there. That makes s to the 9th power. And here you have a t to the -1 and t to the 4, and when you add those, you get t cubed. All right, so we'll jump down here and look at D, right below it. We'll move this ink up a little bit. So I'm going to combine the a's first and the b's, and then move them up or down if I need to. So a to the 3 divided by a to the -3 divided by a to the -5. You would take and combine those by taking -3 and subtracting -5, and you will get a squared. When we combine the b's together, b to the 4 minus b to the 5 makes b to the -1. The question asked you to only write positive exponents, so I guess you would take that and write that as a squared over b to the 1. You would write it in that manner. Okay, so if we have in F, if we look, you've got a power of a power, so that cube works on the 2, on u squared, and on v cubed. So that, it's getting messy. So you would, the first bracket, you would get 2 cubed, which is 8. You would get u to the 6 and v to the 9. That's the first bracket. The second bracket, you will get 3 to the -2, which is 1 over 9. You will get u to the -6, and you will get v to the -2. Okay, so combining those, you would have 8/9 for your constant. You just take the 8 and the 9 together. You have u to the 6 and u to the -6. That makes u to the 0, which you don't need to write. That's just 1. And then you have v to the 9 and -2, so that's v to the 7. So you would get 8/9 v to the 7th power. Looking around, like most of those powers and those rules we've seen are all about the same. You can look at one that's supposed to be really difficult, I guess. And down here in L, if we try and tangle with this thing, so we'd apply this 3 exponent to everything on the inside. So you would get a to the 6, b to the -9, x to the -3 in the bottom, and y to the 6th in the bottom. The other bracket then would be x to the -2, b to the -1, a to the 3/2, b to the, y to the 1/3. If we start combining those, you look at the a's. I have a to the 6 and a to the 3/2. You subtract those. 6 minus 3/2, so that's 12 over 2 minus 3 over 2 would give 9/2 for a. So my a's are now dealt with. I have b to the -9 and b to the -1 being multiplied together. So that would make b to the -10. In the denominator, I would have, also in the numerator. So we've got our b's taken care of. Now I've got an x to the -2 up top, and you're subtracting -3. -2 subtract -3 is 1. So my x's are now taken care of. The last thing to do is combine the y's together. In the denominator, you have y to the 6 times y to the 1/3. That means you take 6 and add 1/3. So 6 is 18 over 3 plus 1 over 3 is a y to the 19/3. All right, so the only thing that we have that would be quote unquote broken in terms of our directions are that you have a negative exponent here for the b. So if it's a negative exponent up top, you just shove it downstairs and make it a positive exponent. So you would see a to the 9/2, x to the 1, then in the denominator b to the 10th power, y to the 19/3. All right, so there's other ones there, but we'll move to the next section. So the next set of questions dealt with taking a logarithmic expression like you see and writing that in exponential form. If you recall, the 2 that's here is the base. So when you write this in exponential form, the base is 2. 6 will be the exponent. And the answer you're taking logarithm of is the answer to the exponential. So 2 to the 6. So you have 2 to the 6th power equals 64. All right, so following the same pattern, log to base 10 is base 10. The exponent is the answer, -2. And this 0.01 is what that comes out to. 8 to the 3rd power in an exponential form is equal to 512. Okay, so changing an exponential equation into, changing a logarithmic equation into an exponential equation, you just follow the patterns you were shown. If we check out number 2, if we're going to take it and write it as a logarithm, you just do the reverse. So it is log, the base is 2, so it's log to base 2. And the answer is what you're taking the log of 8, and that answer will be 3. Okay, so to the point in this question, if you were faced with this, and instead of a 3, you had an x here, and you wanted to know 2 to what power is equal to 8, you would take log of both sides, log to base 2 here, and log to base 2 there, and log to base 2 of 8 will be 3, and the log to base 2 of 2 to the x will be x. It will go away, and x will equal 3. So you're starting to see what you would use these logarithms for. They undo a power. If you want to undo this power of 2 to the 3, you take the log to base 2 of it, and the answer comes out to 3. Okay, so if we took the log to base 10 this time, because it's a 10 base, so log to base 10 of 0.0001, the answer will come out to -4. And here, log to base 4 of 0.125 is equal to -3/2. Okay, so that's writing your exponential expression into a logarithmic form. And now we'll try the last one in number 4. We'll try and solve some of these for x. And so you're going to write it in exponential form and see if we can figure it out. Okay, so log to base 2 of x equals 10. If we wrote that in exponential form, you would say 2 to the 10th power equals x. What this was asking was, if you were to you want to figure out what do you take log to base 2 of to have it equal 10. It has to be whatever 2 to the 10th power is. And that answer comes out to 1024. Okay, so let's look at the next step here. You're going to have 10, that's the base. 2, the answer is the exponent, so 10 to the 2 equals 3x plus 5. So if you were trying to solve that now, you would have 100 equals 3x plus 5. Subtract 5 both sides, you'd have 95 equals 3x, and x is 95/3. Not a pretty number, but it works nonetheless. Now this last one goes the other way. This last one, you're going to take this exponential function and turn it into a logarithmic function. Okay, so log the base is 2 of 3 equals the exponent 1 minus x. Okay, so if you're going to solve that for x, I would bring the x to this side, log to the other side, and you would have x equals 1 subtract log to base 2 of 3. And in the absence of knowing how to work that out, that's at least the way you would leave the expression solving it for x. Okay, so there are some of the questions I asked you to look at, and we're going to take this up and go a little bit harder with the next section. Hope you've learned something.